This is a well-known display of classic programming. As you see, program needs rules and data to generate answers. However, in machine learning, we don't need to define the rules. Machine learning takes data and answers and find the rules itself. Let's look at it in a different way. Assume that we want to label a cost variable as expensive or cheap. In classical programming, we define the rule as shown in the slide, then program can generate the answer based on this rule. For this example, the program will label $5,000 as expensive because it is bigger than 1,000. In machine learning, we give data with answers, with outputs, sometimes without answers. With enough data, our model can generate the rule. By this way, when a new unseen data is given to the model, it can classify according to that rule. To make it clearer, I want to show a graph. If there is enough data, machine learning can generate the right rule. However, if data is not enough or representative, if it is not representative, it will produce wrong rule as you see in the right graph. This is important, and we will see more details for the data preparation, processing parts. But for now, don't forget that machine learning needs data, and mostly it is big data. Okay, I hope you get the main idea behind the machine learning. Now, I want to explain when machine learning is needed and successful with two examples. First example is phishing detection. As you estimate, there were some solutions, some other approaches before machine learning to detect phishing attacks. By the way, phishing is a cyber attack to deceive users to get their credentials or money, their private information. And usually it is started by an innocent appearing email or SMS or any communication channel. And one of the traditional approaches for this problem is blacklist-based approach. It is quite simple. When an attack is reported, you add the URL of that phishing website to your blacklist. By this way, if another attack is performed through the same URL, the system can detect and block that attack. Of course, it is not sufficient for new attacks or attackers change the URL. You can prevent some attacks, but still it's not enough. So researchers developed another approach, rule-based one. It is better than previous, but still it is not completely sufficient. In this approach, you can define rules thanks to your observations, your analysis. For example, think that if you analyze the phishing emails, you can notice that there are some frequent words like for you, credit card, submit, free, etc. Then you can define rules based on these observations and detect phishing attacks. However, it is not enough because if problem is not too complex, maybe you can cover all rules. But if it is too complex, defining all rules will be impossible. And arranging the relation between these rules also make the problem quite complicated. Also, attackers can notice your rules and change their text or time, etc. So some better solution is required. At this moment, machine learning-based approach provides better solutions, provided that model is feed enough data and representative data. After all this long explanation, we can say that there are alternative approaches. Machine learning should be used if it provides better solutions, and usually if the problem is too complex, machine learning can be preferred instead of traditional approaches. Okay, second example is speech recognition application. Let's assume that you want to distinguish the sounds of 1 and 2. You can code it. You can code your program based on the tones of these 1 and 2. And it will be hard, but not impossible. However, if you try to distinguish all English words in the dictionary and from 1,000 different people or from different pronunciations, coding with traditional way will be impossible. Before machine learning, translator applications were terrible. Some of you can remember that. However, today, thanks to machine learning, we can produce nearly perfect applications. For instance, you can inspect Google Translate. Google Translate's performance is amazing, especially in this application field in the speech recognition or etc. As a summary, we can say that machine learning is good at if problems are too complex for traditional approaches like we saw in phishing example, or if the problem have no known algorithm like in speech recognition example. In other words, if you don't need to use machine learning and if you can use a more simple, cheaper solution, you shouldn't use machine learning. It's not always the best way. Okay, last question for this section. As we saw in the definitions, machine learning was defined by Arthur Samuel in 1959. And most machine learning algorithms were invented before 2000, let's say millennium. Especially in the last 2 decades, with deep learning success, machine learning has become popular. So my question is, why now? Why did not machine learning become popular, let's say, in 1970s, 1980s, or 1990s? Even though it is quite old, as you see, Arthur Samuel defined it in 1959. Of course, there are some reasons, and the first one is machine learning needs data, and actually big data. And after the digitalization, we can have big data. Now everything is digital. Also, this data is accessible by researchers, and not all of them, but important part. And secondly, huge improvement in computational power. The iPhone 6 could perform instructions 120 million times faster than Apollo 11, which was the spacecraft landed on the moon in 1969, probably. Today, with quantum computers, this difference is getting increasing dramatically. So the second reason is computational power. And thirdly, researchers, companies are developing new algorithms. For example, Google developed BERT, which is a language model, and it's quite good at natural language processing tasks. So the third reason is the latest algorithms developed by researchers and the companies. And the fourth one, of course, other technological developments. For example, today everyone has smartphones and can take pictures. But in 1990, pictures of cats were limited. Today, billions of cat pictures are available on the internet. Or by social media applications, we can obtain profile data of target users, for example. And lastly, of course, like in everything, economic reasons. And the success of machine learning, deep learning attracts investments. By these investments, more giant projects are executed. These also help machine learning success and the popularity, of course. Okay, until now, we answered what is machine learning, what is not. What is the difference of machine learning, and when should we use it? Why is it so popular and successful now? In the next section, we will see some application examples to understand current capabilities of machine learning. Maybe you can take inspiration from these examples for the research for your project.